Hi everybody, and welcome to our support video for our 1.2 assignment here. Winnie's still in my lap, so I get apologies if any noises come from him, but I think he wants to learn pre-calc too, so he might just be with us for a bunch of these videos. So our first question here, we are taking a look at identifying the domain of a function. If you look on the fourth page of your notes, or the last section that we covered in the video, we talked about three specific types of functions where we have to do some solving. So these are the last two questions on the book widgets for 1.2, so I wanted to take a moment to go through some of that solving again. So if you see a function that has a square root in it, it is allowed to be equal to 0. It just has to be something that is greater than or equal to 0. So you can't have any negative numbers in the square root. So just for the square root. So if you ever see a function that has a square root as any piece of it, that's what we want to make sure is greater than or equal to 0. The 7's outside of the square root, so we really don't care about that. We just want to look at what is inside of our square root here. So this 2x minus 8, that's what we want to make sure is greater than or equal to 0. So from there, all we're going to do is just solve. So take your inequality, move 8 over, divide both sides by 2, and we're left with 2 is greater than, or sorry, x is greater than or equal to 4. So that's actually, if we take a look at our interval here, 4 greater than or equal to is going to look like this. So our solution for our domain, we can either write it as x is greater than or equal to 4, or we can use the interval notation from 4 to infinity. So either of these, I'll put them in yellow. This works as an answer, or this works as an answer. It just depends on what the question is asking you. So in this case, again, if you have a root greater than or equal to 0, solve from there. Our second question here, this is our reciprocal function, or basically a case where we have a variable in the denominator. So for these ones, what we want to do is take your denominator, so just take the bottom, and we're going to want to set that equal to 0. So remember, the bottom cannot be 0, so what we're actually solving for is a non-answer. We're solving for what it's not equal to. So again, bottom can't be equal to 0, so we can just treat it like normal, but just have to remember it's a not equal to question. So add 30 to both sides. We have 15x on the left and 30 on the right. Divide both sides by 15, and we have x and then 30 divided by 15. Feel free to punch that into your calculator just to double check. We'll get us 2, and x is not equal to 2. So our domain is all numbers where x is not equal to 2. So anything except for 2 is fine. If you wanted to write this as an interval, what this would look like is we have a gap at 2, and everything else is fine. So from negative infinity to 2, we have a gap. So remember, gaps, we put unions, and then from 2 to infinity. So as a final answer, you are allowed to write all numbers x is not equal to 2, or you can write interval notation, basically saying it's everything except there's a gap at 2. So hopefully that support helps. Again, just like the two questions on the bottom, there are special cases when we're doing some algebraic solving for excluding